just in the process of stripping the engine down. Some things I want to do. Even though the engine only had about 60,000 kilometers on it, I don't know if you can see down inside there, but the intake valves are all covered in carbon, so I got to pull the heads and clean those up. But overall, the engine's showing minimal signs of wear. Coking of the valves is a well-known problem on the first-gen Ecoboost engines. The direct injection just doesn't wash the back of the valve free of the carbon deposits from the PCV. So I looked for different chemical cleaners, take the carbon off. Couldn't find anything decent, so I figured I'll just scrape it off. So I sharpened up a piece of cherry here to a chisel point, and about a minute of scraping, and the valve looks pretty good after that. And then I just took and cleaned it off with a soft wire brush after that, and the grind is still looks perfect, so no problem with that. These are the adapter flanges to make the Ecoboost head to the IndyCar headers. Ports are a fair bit different in size, so I got to smooth that out. Even though I made the slots in the flange tapered, I still got to take a fair bit of material out of the wall of the Ecoboost ports. So fortunately, the walls seem fairly thick in that area in the ports, so it shouldn't be a problem. So we turned up some step plugs out of aluminum to block off the direct injector hole, and they're fixed on the back with set screws, so no turning back now. The Ford engineers have really shrouded the intake valves here. You can see the size of the ports really reduced. This is a sharp lip here, and a ski jump on the back of it. So maybe that works for low-speed torque. I don't know, but it's not going to do anything for horsepower. So I've been opening the ports up, just trying to not to open the bowl area too much, but take away that lip, because it's really going to be a problem for airflow. Port matching on the heads is done, intake and exhaust, and I scalped out where the fuel nozzles inject. It looks like it's pointing pretty much straight at the valves, which is perfect. And everything turned out good. So another loose end, I've got to finish off the oiling system, the lubrication system first. So I've got this dry sump pump mounted up. I did that a couple of years ago, and I welded this oil pan up a couple of years ago as well. Except I never welded the fittings for the suction tubes in there, so I'm doing that now. Anyway, I've got these adapters here. They're 12 AN on one side and 3/4 pipe thread on the other side. And I bored it out so there can not be screens inside. And think of what the screen is. If I blow up the engine, hopefully that screen prevents it from completely trashing the dry sump pump, because those pumps are pretty darn expensive. And then I've got these braided stainless lines that are off of NASCAR. And I'm just machining up these bungs right now so I can weld these into the wall, and then the fitting will go in. And then these are the suction tubes. I got to finish those still. They'll get welded onto the end of the fitting here after I got the screens in. So that's the plan. The advantage of the dry sump system. Let me drop the engine down 6 or 8 inches in the chassis. So that's good, and also gives you oil pressure during prolonged heavy cornering. Disadvantage is the whole thing's pretty complicated and maybe not a DIY project, but anyway, it's coming along. So I've got all the scavenge tubes installed now. That worked out okay. Since I mounted the dry sump pump where the alternator was, I'm going to have to move the alternator to the other side. So I got to do a little bit of design work for a mount over here. Still working to finish up the lubrication system, loose ends. So this is a scavenge line out from the dry sump pump through a coarse filter, feeds up. So this is a mix of air and oil coming out of the scavenge pump, and then it goes into 1 or 2 ports in the dry sump tank. So primary function of this dry sump tank, besides being a reservoir for oil, it's also designed with baffles inside to separate the air out of that mixture. So I don't want to be drawing a vacuum inside of the engine, so I'm going to equalize the pressure with this other vent line that's going to run back and tee off. It'll feed into the back into the engine and the valve covers, probably the PCV ports. And then any extra air from blow-by will get vented overboard. So, you know, made this simple, welded up the simple catch can. It's single port in, and then there's a series of baffles inside here to try and condense some of the oil vapors out of that gas that's coming back out of the tank. So, you know, series of baffles in there, and then at the top I've got this sintered one of these sintered bronze filters that I've installed in here, and then it just vents through a couple of simple air filters overboard. So anyway, that's the plan. Let's see how it works. Looks a bit funky, but this is the mount for the alternator and idler and the belt tensioner, serpentine belt tensioner, all in one piece. It's a bit fussy making it, but looks like everything's going to line up. So I got the alternator and drive system installed here. The alternator's down nice and low, which is good for weight distribution. And unfortunately, I couldn't put it up any higher because the block really kicks out there, and it was going to put the alternator way too close to the headers. So it meant I had to put this this idler in here to get the belt up over the front drive shaft. Anyway, looks like everything's going to work. It's pretty tight for clearance here. I don't think that's going to work if the belt stretches. I may need a slightly shorter belt. And then that tensioner is off a Chevy Silverado. Ecoboost tensioner wasn't going to work in there. Anyway, got everything set up. Yeah, on to the next task. So I talked about mounting a burst panel onto the intake plenum. I was concerned if there was a backfire and the throttles were closed, it would distort the aluminum plenum. But I've done this instead. It's a blow-off plate, so I welded a 1/2-inch thick base plate on here. It's got 2 1 3/4 holes in it, and they're sealed with O-rings, sealed by the pressure of these springs here, so it'll probably relieve around 100 psi. And then I just got pressure taps for the map sensor and a boost gauge and a few other things. I've got the engine reassembled, so I'm ready to put it back in the chassis. Made a few more parts. Made this this housing here for the water pump. It's cool water feed. Still waiting on the silicone coupler. And turned up a smaller idler pulley for that serpentine drive, so that solved some of the clearance issues. Lots of little fittings down here to accommodate the oil and coolant to and from the turbo. What else? Modified the fuel rail, so those are 300 series stainless, thin wall though, 30 thou thick, so it was a bit of a challenge welding those up. I made this blanking plate for where the high pressure fuel pump used to mount. I'm gonna wait till I get the engine back in the chassis to finish off the need a thermostat housing, need to finish these coolant lines. But things are coming along. These headers, these are really nice pieces. So these are Honda IndyCar headers, and they're made out of Inconel, and they are absolute works of art. Whoever made these, serious craftsman. The welding's just unbelievable on them. So anyway, next step, back in the chassis.